Identification of carbonate ion and sulfate ion. This is today's lesson. In this lesson, we are going to learn how to identify carbonate ion and sulfate ion and how to distinguish them. So let's begin. Identification of carbonate ion and sulfate ion and distinguishing between them. For this, we need 2-3 milliliters of stock solution of carbonate ion or sulfate ion. This is solution of carbonate ion or sulfate ion. Here, this solution contains either carbonate ion or sulfate ion. We have to identify carbonate ion and sulfate ion and distinguish between them. We need another solution. Here, solution of barium nitrate. Now, a few drops of barium nitrate solution is added to the solution of carbonate ion or sulfate ion. Immediately, here we observe white precipitate. This white precipitate confirms the presence of either carbonate ion or sulfate ion. But to distinguish carbonate ion and sulfate ion, we need diluted hydrochloric acid. In this test tube, diluted hydrochloric acid is added. Then, when this precipitate disappears, then the solution contains carbonate ion. But if this precipitate doesn't disappear, then the solution contains sulfate ion. What is the reason behind this? In this lesson, we are going to learn. So, let's go to the detail. When the solution contains carbonate ion, suppose salt is sodium carbonate, in which barium nitrate solution is added. Barium nitrate solution. Then there is formed barium carbonate, which is insoluble in water. So it deposits as white precipitate. And here byproduct is sodium nitrate. This white precipitate indicates presence of carbonate ion in the solution. But if it is solution of sulfate salt, suppose sodium sulfate, barium nitrate solution, in this case as well, white precipitate of barium sulfate is formed. Here byproduct is sodium nitrate. So this white precipitate indicates the presence of sulfate ion in the solution. So solution contains either carbonate ion or sulfate ion. This white precipitate indicates the presence of carbonate ion or sulfate ion. Now let us try to know how to distinguish sulfate ion and carbonate ion. Distinguishing between carbonate ion and sulfate ion. For this, diluted hydrochloric acid is added to the solution. Diluted hydrochloric acid is added to this test tube, that is barium carbonate, which is precipitate solid. Diluted hydrochloric acid reacts with barium carbonate. It means barium carbonate dissolves in diluted hydrochloric acid to form barium chloride, and carbon dioxide and water are formed as byproduct. In this case, diluted hydrochloric acid reacting with barium carbonate forms carbonic acid that promptly changes to water and carbon dioxide, because this is an unstable acid. So when hydrochloric acid, diluted hydrochloric acid, reacts with the precipitate of barium carbonate, with the barium carbonate precipitate, it means white precipitate disappears reacting with diluted hydrochloric acid. Then this disappearance of white precipitate reacting with diluted hydrochloric acid confirms the presence of carbonate ion. But when diluted hydrochloric acid doesn't disappear, when diluted hydrochloric acid doesn't disappear the white precipitate, it means here no reaction happens. This meta confirms the presence of sulfate ion in the solution. Let us consider this reaction happens here. Let us consider then barium chloride and sulfuric acid will be formed. Sulfuric acid, which is stronger acid than hydrochloric acid. So hydrochloric acid must not produce stronger acid, sulfuric acid. For this reason, this reaction doesn't happen. That is simply when this white precipitate disappears reacting with diluted hydrochloric acid, then this is carbonate ion. But when this white precipitate doesn't dissolve in diluted hydrochloric acid, then the solution contains sulfate ion. Now let us try to know why this is soluble in water, this is insoluble in water, Then barium sulfate is insoluble in water, and the reason behind these reactions, let us try to know the matter one by one. First of all, barium nitrate. This is soluble in water. Let us see the structure formula of this compound. This is coordinate covalent bond. Here, the attraction between barium ion and nitrate ion. Here, single charge. So, in this case, lattice energy is lower than hydration energy. That means, here, hydration energy can overcome the lattice energy, or lattice energy cannot overcome the hydration energy. So, because of the less lattice energy, this is soluble in water. But in case of barium carbonate, let us see the structure formula of barium carbonate. This is barium carbonate. Here, strong lattice energy. Carbonate contains 2- charge. So, in this case, strong lattice energy gets created. Because of this strong lattice energy, this is insoluble in water. Similarly, barium sulfate. Because of this strong lattice energy, sulfate contains 2- charge. So here, strong lattice energy gets created. That is why barium sulfate also insoluble in water. Barium nitrate is soluble in water, but barium carbonate and barium sulfate are insoluble in water due to the lattice energy difference. Reaction between barium carbonate and diluted hydrochloric acid. Here, chloride ion. We know chloride ion is more reactive than carbonate ion. We know this from electrochemical series of anions. So, this chloride ion replaces this carbonate ion to form barium chloride, which is soluble in water, and this proton from acid combines with carbonate ion to form carbonic acid that changes to carbon dioxide and water expeditiously, promptly. Carbon dioxide and water. So here, chloride ion is more reactive than carbonate ion, so it can replace the carbonate ion from barium carbonate. For this reason, barium carbonate forms soluble barium chloride. Now, let us see about the barium sulfate. Diluted hydrochloric acid, which forms, suppose, barium chloride and sulfuric acid. Here we know as well, chloride ion is more reactive than sulfate ion from electrochemical series of anions. So this reaction was supposed to happen, but here another matter dominates the reaction, that is, sulfuric acid is stronger acid than hydrochloric acid. So weak acid, hydrochloric acid, cannot produce stronger acid sulfuric acid. Identification of carbonate ion and sulfate ion. Thank you very much.